dears, this is Raji. In this video, we are going to learn aldol condensation reaction. You can find this topic in class 12 organic chemistry related to the chapter aldehydes and ketones. So, you will be getting questions related to self-aldol condensation, cross-aldol condensation and intramolecular aldol condensation. In this video, we will be discussing only self-aldol condensation. So, we are going to discuss the real mechanism of aldol condensation reaction. After that, I will tell you a duplicate mechanism. And we will be answering a lot of multiple choice questions also using this duplicate mechanism. Okay, so let's start with aldol condensation reaction. So, first of all, we should understand what is this aldol condensation reaction. Remember, this reaction will be exhibited by aldehydes or ketones which are having alpha hydrogen atom. Okay, so this is the functional group. Okay, aldehyde that is present in this compound, acetaldehyde, which in turn is directly attached to this carbon atom. So this is alpha carbon atom, and the hydrogen which in turn is directly attached to that is known as alpha hydrogen. We have already discussed about alpha hydrogen in the previous video of Cannizaro reaction. So you can just go through that also. Okay, so aldehydes and ketones which are having alpha hydrogen atom in presence of dilute alkali to form beta hydroxyaldehyde. See, this is the functional group again. Okay, this is the alpha carbon atom and this is the beta carbon atom. At the beta position, you can see one hydroxyl group attached to that. So we call it as beta hydroxyaldehyde or aldol. You can say that in the same molecule you can find aldehyde group also, OH group also, alcohol group also. Hence the name aldol. Okay. So the compound obtained if you are heating in presence of some dilute acid, what will happen? Readily one molecule of water will be eliminated and you will be getting an unsaturation between alpha and beta carbon atom. So alpha beta unsaturated aldehyde you will be getting. As this reaction will be associated with the elimination of small molecule like water, this is also known as aldol condensation reaction. Got it? Yes. Now let's see the mechanism of aldol condensation reaction. We know that this reaction will be taking place in presence of a dilute alkali. Okay. So this nucleophile will be OH minus ion. This OH minus ion will be having a tendency to attack this hydrogen atom. Why? So remember, whenever this carbonyl group is attached to an alpha carbon which in turn is attached to an alpha hydrogen atom, because of the minus I effect of this carbonyl group, it will be having a tendency to pull the electron density between this carbon-carbon bond towards itself. Because of that, there will be the development of a partial positive charge on the alpha carbon. So what this alpha carbon will be doing? It will be having a tendency to pull the electron density between carbon and hydrogen towards itself, right? Thereby, this hydrogen will become acidic. Okay. That's the reason this nucleophile will be going and readily abstracting this hydrogen from this compound. Got it? If the nucleophile is abstracting this proton, one molecule of water will be eliminated and that will result in a negative charge that will be present on this carbon atom. So write the product. You will be getting CH2. There will be a negative charge present on it and C double bond OH. This will become a strong nucleophile which in turn will be going and attacking another molecule of acetaldehyde. Write that also. So this nucleophile will be going and attacking this electrophilic center that is present on the carbonyl carbon. Now write the product obtained CH3CO minus you will be getting. Okay, this hydrogen will be present and you will be getting CH2C double bond OH. Right. But see the product of the reaction in which a negative charge is present on oxygen. It is localized. There is no possibility of delocalization or resonance. Because of that, this will be unstable. So it will try to abstract a proton from water. That will be the next step of the reaction. Water, we can write it as HOH. So this proton will be abstracted by this oxygen which is having a negative charge on it. So as a result, what will be the product of the reaction? That O minus will be getting converted into an alcohol group, OH. A hydroxyl group is present at the beta position, right? So this one is beta hydroxy aldehyde and generally we call it as an aldol. So if someone is asking what's the mechanism of aldol condensation reaction, you can write these steps. Okay. But in order to predict the product of the reaction easily, we have an easy and an alternate mechanism for that. We are going to learn that. Okay. Yes. See this one. For your exam, you will be getting questions like this. 2 molecules of acetaldehyde in presence of dilute alkali. Predict the product of the reaction. So you don't want to write the entire mechanism. They are asking only the product of the reaction. Okay. So how to predict it easily without writing the entire mechanism? You write along with me. We are writing 1 molecule of acetaldehyde like this to understand. Okay. Whenever you are writing another molecule of acetaldehyde, you keep one alpha hydrogen facing this carbonyl carbon like this. Okay. Now write C double bond O H also. Okay. In presence of alkali, what will happen? You break this bond of carbon oxygen. You attach this hydrogen to this oxygen. And then you will be attaching these 2 carbon atoms together. Directly you are going to write the product of the reaction. Write it CH3. You are breaking this carbon oxygen bond. So that bond will be getting converted into OH. Why? This hydrogen is also coming and attaching with oxygen. So it will become an OH group. And this hydrogen is already present along with carbon. Then CH2 and C double bond OH also will be there. You got the product directly. You will be getting beta hydroxy aldehyde, or this is known as aldol. Right. Beta hydroxy aldehyde, upon heating in presence of some dilute acid, what will happen? This molecule of water will be eliminated. Right. Then you will be getting a double bond between these 2 carbon atoms. Write the product of the reaction. You will be getting CH3, CH double bond, CH, then C double bond OH. Okay. Alpha, beta unsaturated aldehyde you will be getting, and in this case it has got a common name. What's the name of that? This is known as croton aldehyde. Okay. You should remember it. Yes. Now, in the same way, is it possible to predict the product of the reaction when 2 molecules of acetone will be reacting with dilute sodium hydroxide solution? Using the same method, we will write it. Write along with me. I am writing acetone like this. CH3, C double bond O, CH3. Whenever you are writing next molecule of acetone, keep this alpha hydrogen facing this carbonyl group. Then C double bond O CH3 you can write. In presence of a base, what will happen? You can break this double bond and add this hydrogen to this oxygen. Okay. And you can join these 2 carbon atoms. Write the product of the reaction. You will be getting CH3, C double bond O will become OH. Then CH3, then to this carbon atom CH2 will be attached, and to that C double bond O CH3 will be formed. Okay. In this beta position a hydroxyl group is present. So you are getting beta hydroxy ketone. Usually we call it as ketol. Okay. The same compound obtained upon heating in presence of dilute acid. What will happen? 1 molecule of water will be eliminated. Okay, write that also. See, this molecule of water will be eliminated and you will be getting a double bond. CH3C double bond CH. Here one CH3 group was there and C double bond OCH3. This will be the product obtained. In between alpha and beta position, you will be getting unsaturation. Now, one more doubt may come to mind, why we are removing water as HOH from this carbon atom. Hydrogen can be removed from this carbon also. Why it is not so? Reason is that if you are removing a hydrogen atom from this carbon atom, that will result in the formation of a bond between alpha and beta, which in turn is in conjugation with this carbonyl group. So, this structure will be having more resonance stability. So, due to that, if you are heating this molecule, hydrogen will be replaced from this carbon only. So, what will be the final product of the reaction? It will be 4-methyl pent 3N2-on. Okay, it's so easy, right? Now, see this one. These are some questions which were asked in previous year's board paper. Write the chemical equation to illustrate aldol condensation reaction. You can write the statement also and give one example also. You can do that. Okay. Yes. How will you bring about the following conversion ethanol to butanol? It was asked in 2010 paper. So, what is ethanol? Write and see. It will be CH3C double bond OH. We will have to convert it into butanol. See this one, this is an aldehyde and in between alpha and beta position an unsaturation is present. Also, this is an aldehyde having alpha hydrogen atom. So, immediately, the idea should come to your mind that this is aldol condensation reaction. Okay. So, what we will do? 2 molecules of acetaldehyde in presence of dilute alkali, dilute sodium hydroxide. What will be the product obtained? You will be getting beta hydroxyaldehyde. Write it. This beta hydroxyaldehyde or aldol, upon heating in presence of dilute acid, you will be getting butanol, alpha beta unsaturated aldehyde. Easy, no? Yes. See this question. This is a 2017 NEET question. Of the following, which is a product formed when cyclohexanone undergoes aldol condensation followed by heating? Okay, so this is cyclohexanone. 2 molecules of cyclohexanone is going to react in presence of dilute alkali. What will be the product of the reaction they are asking? Using our same duplicate mechanism, easily you can predict the product of the reaction. For this kind of compounds, you can give a number for the carbonyl carbon also and the one that is holding that alpha hydrogen also. Okay. The alpha hydrogen of the second molecule will be coming and attacking this carbonyl group we were telling. Right now. So, break this carbon oxygen bond and attach this hydrogen over here. And we were telling that, this carbon 1 and this, carbon atom holding that alpha hydrogen atom will be joining together. Carbon 1 also, carbon 2 also. So, I am writing the compound like this only. As they have given in the options. Okay. Now think about the position of the carbonyl group and OH group also. In this case, OH is with this first carbon atom. So, I am drawing OH over here. Correct? See, carbon 1 is now attached to carbon 2. Right? So, where is the position of this double bond? It will be over here. Correct? No? Double bond O. Now, if you are heating this compound, from where hydrogen will be eliminated? From carbon 2. Why? That will result in a carbon-carbon double bond which will be in conjugation with the carbonyl group. So, that will be resonance stabilized. So, finally, our structure will be looking like this. Find out. This answer is there in the option. Yes, that is the first one. Easy. Yes. Now, see this question. This is a pre-medical question. This was asked in 2008 paper. Acetophenone, when reacted with a base C2H5ONa, yields a stable compound which has the structure. So, acetophenone will be looking like this, right? No? It is a ketone having alpha hydrogen also. And they have told that it is a base. So, which will be the reaction taking place? It is nothing but self-aldol condensation reaction. Using the same duplicate mechanism, we are going to write the product of the reaction. First of all, we are writing the ketone like this. When you are writing the next molecule, you will have to keep the alpha hydrogen facing towards the carbonyl group. And then C double bond O C6H5 you can write. Then break this carbon oxygen bond, attach this hydrogen and join these two carbon atom, right? So you will be getting beta hydroxyketone or ketol. If you are heating this one, what will be the product of the reaction? One molecule of water will be removed and you will be getting a double bond in between these two carbon atom. Again, we don't want to write the product. See, already we got the answer. It is option C. It's so easy, right? Yes. We will be discussing the cross aldol condensation and intramolecular aldol condensation in the upcoming videos. Till then, bye for this time. You keep on working hard. Thanks for watching.